Okay, in this game we will be rolling a pair of dice, and each of the dice has a different color. So one of them is going to be blue and the other one is going to be gray. And the dice have the numbers 1, 2, 3, 4, all the way through 6. So when you roll them, you may see something like this. Let's say 1 in blue and, I don't know, 4 in gray. Or you may see a 3 in blue and a 2 in gray, and so on and so forth, okay? So the first thing they want me to do in this game is to list all the possible outcomes, and they want me to use compact notation. So what I'm going to be doing is writing things like 1, 4 or 3, 2. So what does it mean to write 1, 4 or 3, 2? It means that 1 is going to be the blue die and 4 is going to be the gray die. Or in other terms, 3 is going to be the blue die and 2 is going to be the gray die. So let's make a list of all the possible things that may happen in this problem. So the first thing that could happen is the blue die could be 1 or 2 or 3 or 4 or 5 or 6, whereas the gray die can stay 1 on all of those choices, okay? Then in the same way, now the blue die could go 1, 2, 3, 4, 5, 6, and the gray die could be 2 or 3 or whatever. So we're gonna make a list of all the possibilities. So there's the list of possibilities. So for example, if I select one, for instance this one right here, what does it mean? It means that my blue die gave me 4 and the gray die gave me a 5. So that's what that one means, okay? On the other hand, this one over here would be a 5 on the blue die and a 4 on the gray die, and so on, okay? So that's pretty much all the possibilities for this, for this experiment or for this game, okay? So now let's try to answer these questions using that table. By the way, how many of these there are? There are a total of 36 possible choices. So the total is 36 possible outcomes. Okay, cool. So now what's the probability that the numbers are the same? Okay, so what's the probability of you rolling the 2 dice and you get the same numbers? So like 1, 1 or 2, 2 or so on. So what I did is I copy pasted the table above and I've highlighted the possible events where the 2 numbers are the same, and now I'm going to calculate the probability. Okay, so the probability that the numbers are equal is going to be pretty much 6 divided by 36, which is the same thing as 16.67%. So that's the end of that one. Okay, now what's the probability that the sum of the numbers is 5? So again, looking at the original setup, what kind of numbers will add up to 5? So think of it, would 2 plus 2 add up to 5? No. What about 4 and 1? Yes, that's a choice. What about 5 and 1? No, that's way too big. So let's again copy paste and figure out which ones add up to 5, highlight them and count them. Okay, so I've selected the choices that add up to 5, and now the question is, what's the probability? So the probability of numbers adding up to 5, so the sum is 5, is gonna be equal to, again, this is gonna be 4 divided by the total number of choices, which is 36. And that's gonna be 11.11%. Okay, so hopefully that's clear. Now the question is, what's the probability that the sum of the numbers showing is at least 9? Okay, to say that the sum is at least 9 means that your sum could be 10 or 11 or 12 or so on, but now the question is, does it include 10 itself, or does it include 9 itself or not? And the answer is yes. If you want to be at least 9, that means you can be 9 or more. So I've highlighted all those possibilities, and so there's 4, and then 37, and then 2, 9, 10 out of 36 choices. Okay, that's the end.